Science begins with curiosity. We often ask questions like how and why. And as human beings, we want to understand the world that surrounds us. For example, if you are looking at a plant, you may ask questions like how do plants grow? What things are necessary for them to develop? Or if you take a look at something more simple like a rock, you may ask questions like how do rocks form? How long does it take for them to form? These are some questions that scientists have done and look for an answer. Now, they depend on a wide range of skills and tools to find those answers. Let's analyze some of them. As a scientist, you'll need to know how to use certain tools, whether it's a scale or a microscope. You need to be familiar with the functions of the tool. A science lab is a place of discovery, but it can also be a place of danger. So you must be very careful when you enter to a science lab. It's true that because of the pandemic, we're not using the school's science lab, but there are some basic rules that I want to teach you. One of them is always to wear a lab coat, like the one I'm wearing. It needs to have long sleeves to protect your arms from any substances. If you are a girl, you should pull your hair back when you're doing an experiment. Also, you shouldn't wear long earrings or rings or any bracelet. It could be dangerous. Another basic rule is not to play inside the science lab because there are different substances. We also have different materials and some tools are very expensive and we need to be careful with them. And always leave your space clean once you finish doing your experiment. Those are some basic rules that you have to remember when you use a science lab. The specific tools scientists use every day depends on which scientific discipline they are involved or in what type of research they are doing. These are some examples. Now we're going to talk about 4 basic skills for scientists. One of the most important skills is observation. Whether you're conducting an experiment, studying an animal in the wild, or digging through the ground to find ancient bones, you need to observe carefully everything that is related to your research. Also, you need to take notes of these observations. If you see something and you think it's not important and you don't write it down, maybe your research will be incomplete and your results will be unreliable. It's very important to keep a record of your observations. When we have a science fair, I ask my students to have a science logbook, which is a simple notebook where they take notes. What kind of things they write in their science logbook? Everything. Everything that happens in that process before the science fair, the day of the presentation. They write down, for example, what options they have or what are the probable projects to present. Then they do a research on the project, and for example, if one day they have a problem with their experiment, they write down all those details, what problems they had, what changes they made. Everything has to be recorded there. They even write the date when those things happen. So this will help them to be successful at the science fair. Another important skill used by scientists is math. Physicists and chemists, for example, use a variety of formulas. Some can be simple, like the formula for velocity, which is distance divided by time, and others can be more complex. But like they use them every day, they end up memorizing these formulas. The same happens in chemistry. You're going to be using some elements more often than others. So you will probably end up memorizing the name of the element, its abbreviation, and even its position on the periodic table of the elements. So don't worry when you study physics or chemistry. You're going to learn a lot of interesting things in both subjects. Other scientists like biologists and ecologists use statistics to study and compare the data they recorded while doing the observations. For example, if a biologist was studying a certain type of plants in a forest, he needs to know, for example, how many plants were affected because of pollution in that area. And he can compare which plants were more affected, and he can hold a research of why those plants were more affected and why the others were less affected. A scientist must be skilled in language and communication because they need to share their results or their research. So also another thing to take in consideration is that most scientists work in teams. So good communication is very important. And that is the reason why when you have a science fair or you're going to work in the science lab, you work in teams because you need to learn how to do it. And when you work in a team, good communication is really important. Now, I want you to review some important vocabulary words for this lesson. If you're a scientist or a science student, you also need to know how to use the scientific method. It has 6 steps. So let's review these steps. The first step is to ask a question. For example, why do plants need sunlight to grow? Then, once you have your question, you start doing a research. That's the second step. You have to become an expert on the topic. So you can research what are the effects of sunlight on plants. Is there any process inside the plant that needs sunlight? Once you made that, you have to create your hypothesis. A hypothesis is a prediction. You can use words like if and then. If a plant doesn't receive sunlight, then once you create your hypothesis, you need to test the hypothesis. And you do that by making an experiment. Inside the experiment, there are two things included: the materials and the procedure. Once you have done your experiment, you can draw conclusions based on the experiment and all your research. And finally, you have to report your results. Was your hypothesis correct? Yes or no? Now, there is a common misconception between students. They think that if the hypothesis was incorrect, then the experiment failed. But that is not true. You actually learned something. So you can explain what did you learn or why your hypothesis was incorrect. Well, now let's review the main ideas from this video. Well, I hope you found this video useful. Thanks for watching, and until the next one, bye!